Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello guys, I'm Dhiraj and I welcome you all on the Testbook.com, and I'm here to provide the best I have. So guys, once again, I came back with another brand new session for the previous year question of gate mechanical. And right now, my dear, we are going to deal with power plant engineering. We have started the power plant engineering yesterday, right? कल हमने शुरू करा था और कल जहां पे छोड़ा था आज वहीं से इसको कंटिन्यू करेंगे and we'll try to finish on today will be what, my dear? Today we are going to finish the question based on the power plant engineering, right? So before starting the session, let me check that how many people have already joined the session. So my dear, I can see that few people have already joined. So guys, we are going to start the session within 1-2 minutes so that the people will get joined and they will get benefit of this session. And my dear, the people, those who have already joined, they can share and subscribe the channel so that they will get, so that their friends and family member, those who are preparing for the gate mechanical, they will get benefit of this session, right? So my dear, those who have joined first time, those who have came first time in this channel, that I want to let you know, my dear, if you are interested, that is we have textbook pass, and just because of Christmas coming, so my dear, we are giving textbook pass just for rupees 299, and in addition to that, we are giving the Ghana Plus subscription free of cost for 3 months, my dear, and that will be very helpful to helpful to listen to motivational music, right? And my dear, what is new in this Christmas special offer, that is you are getting the textbook pass not for 12 months, it's now has been increased by 2 months, that is 14 months, right? So 14 month ka subscription aapko mil raha hai. And my dear, supposed to be, if you are interested in gate mechanical, then my dear, you are getting the live coaching, gate mechanical live coaching just for rupees 3,999, राइट आपको 3,999 रुपीज में पूरा जो गेट एमए लाइव कोचिंग मिल रहा है. यू कैन एक्सप्लोर द प्रीव्यू क्लासेस एंड डेमो क्लासेस ऑफ इट which is available free of cost in the website as well as in the app, my dear. Okay, and supposed to be, if you're a diploma holder and you're interested in SSC JE mechanical live coaching, my dear, then I want to tell you, you have to fill the application form which is given in the description of this video. इसका जो लिंक है application का वो आपको वीडियो में दिया हुआ है, so आप उसको खोल के देख सकते हैं and you can go through it, right? So my dear, these are the various offers and opportunities for students by the testbook.com. So guys, get benefit of this opportunity. इस अपॉर्चुनिटी का फायदा जरूर उठाएं एंड जो है इसका फायदा जरूर उठाएं. ओके बच्चा पार्टी, एंड इफ यू हैव ऑलरेडी बेनिफिटेड ऑफ इट देन माय डियर, you have to tell your friends as well कि भाई ऐसा ऐसा चल रहा है अभी. ओके, so guys, right now it's 3 PM, so we are going to start the session, right? अब हम लोग सेशन को स्टार्ट करेंगे एंड विल स्टार्ट द क्वेश्चंस. ओके, so my dear, here is the first question based on the power plant engineering, okay, of today's session. See what they said. That said, steam enters a well insulated turbine, expand isentropically throughout. Okay, at an intermediate pressure, 20% of mass is extracted for process heating and remaining steam expands isentropically to 9 kilopascal. Okay, no issue. Input turbine, pressure is given, temperature is given, enthalpy is given, entropy is given. Intermediate stage, enthalpy is given. Exit of turbine, pressure is given, that is enthalpy of liquid, enthalpy of vapor, entropy of liquid, entropy of vapor. The 4 properties are given. If the flow rate of steam entering the turbine is 100 kg per second, okay, then the work output in megawatt. We have to calculate, my dear, what work output in megawatt, right? So very good afternoon to all of you guys, those who have already joined. So guys, now we have to calculate, my dear, power in megawatt, right? क्या calculate करना है बच्चा? We have to calculate power in megawatt. So my dear, now we are going to start. But we have to start from the diagram. Okay, so my dear, it is nothing but a case of regeneration right now. So here let me draw the diagram so that you have a clear picture of it कि क्या बोला जा रहा है. Okay, see my dear, it is TS. It is your TS diagram. I hope it's visible to you. It's not visible. Okay, let me off sticker for some time, then I'll on. TS. Okay, bacha party. See. Now I'll draw the TS diagram. See here. Okay. See TS diagram. I'll see my dear. Okay. बच्चा पार्टी लिसन मी वेरी केयरफुली, ध्यान से देखेंगे सब, ठीक है. सो हियर आई गो. ओके, यहाँ पे मान लो 2 है, यहाँ 3 है. ओके, इट इज लाइक दिस. Point number 1, this is point number 2, this is point number 3, right bacha party? Okay, okay bacha party, see here, this will be the diagram, right? 1 2 3, right? Now 4 5 6, right? 4 5 6 7 1, right? See bacha, 4 5 6 7, and it should be what, 8. क्या होगा वो 8 हो जाएगा, राइट ना, 8 हो जाएगा. ओके, सो बच्चा पार्टी सी, here you have mass m, right? They said here you have taken what my dear, point, how much, 20%, that is 0.2 m, and here my dear we have 0.8 of m, right? यहाँ पे 0.8 m आ जाएगा. Am I right बच्चा पार्टी? Okay, because they have said we are using 20%, right? If it is so my dear, if it is so, then my dear listen to me, then how we can calculate the work done, right? Work done developed by the turbine, right? So my dear, you know that we have two turbine, and that should be none other than what, in megawatt. It should be what my dear, it should be WT1 plus WT2. We are going to neglect the pump work, हम pump work neglect कर देंगे. Okay बच्चा पार्टी, we can neglect the work done, right madam? Here I go. So my dear, that means what, H1 minus H2 plus mass flow rate, that is, it should be what my dear, H2 minus H3, right? If it is clear, then I'll go ahead my dear. Now I'll go ahead and you can check it out, my dear. S1 is equal to S3 होगा, yes or no बच्चा पार्टी? S1 is equal to S3, you can check it out over here. यहाँ पे आप देख पा रहे होगे, H1 is equal to S3 because it's isentropic. So my dear, see, can I say S1 is equal to S3? So can I say S3 is equal to SF1 plus X1, what, SFG1, right? SFG1 means what my dear, SG1 minus SF1. Very hello Muthu, you are most welcome in the session. Hello Muthu, you are most welcome in the session. Okay, so here I go my dear. See in the diagram, every property is mentioned, right? Right? Here you can see SG 8.1, right? SF what my dear, SF कितना दिया हुआ, it is given 0.6, right now. S1 is given 6.6, right now. 14 megapascal है ना, ये 14 है, ये 9 megapascal है, right? So my dear, S1 we know that, right? So my dear, here I can say S3 is equal to this one, or you can say let me adjust this equation because there is need to. S3 is equal to what, SF3 plus X3 SFG3, right? SFG3, right now. So my dear, see S3 that we know that 6.6 is equal to what my dear, SF3, that is what my dear, SF3 is given, that is 0.6, and 8.1. Okay, that is 0.6 plus x. What, my dear? 8.1 minus 0.6. So from here you'll get x3, and your x3 will become, my dear, कितना आ रहा है बच्चा पार्टी? It will be how much? It will be none other than बच्चा पार्टी कितना आ रहा है? It will be around 0.8. 0.8 आ रहा है? Okay, that's great. It is 0.8. If it is 0.8, my dear, I can find H3 is equal to HF3 plus X3 HFG3, right? So HF3 will be what, my dear? HF3 will be 174. 174 plus 0.8 Hg. Hg will be 2574 minus 174, right? So my dear, from here we'll get S3, and your S3 कितना आएगा बच्चा पार्टी? Your S3 will be how much? Your S3 will be 2094. कितना? 2094. Now you have everything. 2094 kilojoule per kg, right, बच्चा पार्टी? My dear, you know that W net will be is equal to, that is WT, that is M into H1 minus H2 plus what, my dear? S2 minus S3 into M. So you know that M initially कितना है? 100 kg per second. H1 is given. H1 is how much, बच्चा? H1 it is already given. That is what? 3486 minus H2. How you can calculate H2, बच्चा? H2 2776. कितना? 2776. Right? Given है वो. The question itself. अरे भैया given है. देखो. Right? Plus what, my dear? 80, because 20% तो निकल गया था ना यहाँ से. S2 2776 minus 2094. My dear, you'll get W net, and it will be around, बच्चा पार्टी, how much? It will be around, कितना आ रहा है बच्चा? It is what? What is magnitude? 125.560. 125.560 kilowatt. You can convert it into megawatt. That should be 125.56 megawatt. Okay, and this will be a required answer, bacha. Muthu, you got it? Muthu Kumaran, had you got it this thing? Muthu Kumaran, had you got it this thing? If you get it, then please let me know. Or if you have any kind of a doubt, you can please let me know, bacha bhai. Okay, so here I go, my dear. Chale aage. Here I go. Another question. Here there is another question, bacha. Steam enters a turbine at 30 bar, 300 degrees centigrade. U is given enthalpy. Enthalpy, specific enthalpy, and specific internal energy is given. Okay, and exits the turbine as saturated liquid at, they have mentioned the pressure, that is 15 kilopascal. Specific internal energy, specific enthalpy given. Heat loss due to surrounding is 50 kilojoule per kg of steam flowing through the turbine. Okay, neglecting the changes in kinetic energy and potential energy, the work output of the turbine is, my dear, the work output of the turbine will be what? Yes, Muthu, can you tell me how we can solve? How we can solve? It's very simple, bacha. H1 and H2 is given, right? H1, H2 given. See, they have given H1. H1 is how much, bacha? 2993. They have given H2, that is 226, right? My dear, Q is given. Q is how much? Heat loss minus 50. Right now? And my dear, we have to calculate work done right now. So it's very simple that you know that, and we have to neglect the kinetic and potential energy, steady flow energy equation, my dear. And that is what? H1 plus Q is equal to H2 plus W. Right? So my dear, H1, that is nothing but 2993 minus 50, because it's rejection now. H2 is what, my dear? 226 plus W. So from here you'll get W, my dear, and your W will come around. कितना आ रहा है बच्चा पार्टी? W will be coming around 2717. कितना आएगा बच्चा? 2717 किलोजूल पर केजी, and this will be your required answer. ये आपका required answer होगा. Okay. Yes. Anybody have any doubts? Please let me know. बच्चा पार्टी, be fast. कोई डाउट होगा then please let me know. हाँ जी बच्चा. If you have any doubts, you can ask me. Yes, बच्चा पार्टी. Muthu. Anybody else? Those who are watching, please let me know if you have any doubts. Okay, we'll go for the next. In a Rankine cycle, the enthalpies at turbine entry and outlet. Turbine entry पे इतना है, turbine outlet पे इतना है. Okay, respectively. If the specific pump work is 2 kilojoule per kg, pump work is also given, that is WP. Okay, specific steam consumption we have to calculate. We have to calculate specific steam consumption. My dear, that I already told you. Specific steam consumption is nothing but what, bacha? Is nothing but what, my dear? 3600 divided by the W net kg per kilowatt hour, right? So, my dear, 3600 W net will be what, my dear? They have given, okay, see, my dear, it will be what? 3159 minus 2187 minus what, my dear? 2. So now you have answer. That answer will be, my dear, kitna hai bacha? The answer is how much? It is none other than what, bacha? 3.71. The answer is 3.71 kg per kilowatt hour. Okay. Yes, bacha party. Anybody have any doubts? Please let me know. Okay. So nobody have doubts. Can I go ahead? Here I go. In a steam power plant operating on an ideal Rankine cycle पे, superheated steam enters the turbine at 3 megapascal and 350 degrees centigrade. The condenser pressure is 75 kilopascal. Thermal efficiency of cycle in percentage, my dear. And they have given some data over here. Properties are given right now. So we have to calculate the thermal efficiency. हमें क्या calculate करना है बच्चा पार्टी? We have to calculate thermal efficiency. So how we can calculate? It's very simple, funda. It's very simple, right? Let me draw the diagram first. See, my dear. Okay, this is your TS diagram. One, two, three, four. Okay. Listen to me very carefully. ध्यान से देखना. Okay, बच्चा पार्टी. Listen. Very good afternoon, Ashwini. Ashwini Jangdi, Ashwini Jangid. You are most welcome, dear. Okay, so bacha party here. Here I go. So now this is H1, H2, H3, H4, right? So my dear, you have to calculate eta thermal. So what is, first of all, you should know that is in how many ways you can calculate the final answer. So it's very basic. That is what you can get W net, and you can just divide it by the heat supplied, that is heat added. Right now, it's very simple, right? So my dear, if I go from here, then I have to calculate H1 and H2, right? And bacha party, one more thing that I want to add. It is not, I don't know whether this point number 2 will be located, whether it will be on the car or it may be over here right now. So what I'll do, I'm going to check it out and I'm going to calculate it, right? Okay. So my dear, you know that H1 we know that H1 तो पता है सबको, it is given, right? 3 megapascal. This H1 is given, right? We don't know S2. So my dear, but you know that S1 is equal to S2, right? And S1 is how much? S1 is 6.7428. I can write S2 in form of what, my dear? SF2 plus X2, what? SFG2, right? So my dear, I can write it like what? 6.7428 is equal to what, my dear? SF2. So my dear, see SF2, point number 2, which is at where? It is, let me check. It is how much? It is SF2, that is C, 1.213. 1.213, right? Very good. 1.213, very good. Here, C, it is, again I'll write over here, that is 1.2413 plus X2. What is SFG? SFG means HG minus SF. So it is none other than what, bacha? Here it is given. You can see this, my dear. देखो दिया हुआ, right? So you can directly write 6.2434. Right, my dear. From here you will get X2, and your X2 will come around, bacha कितना आ रहा है? 0.8857. So my dear, now I'll calculate S2. S2 will be what? HF2 plus X2 HFG2, right? My dear, HF2 कहाँ से लाओगे आप? Now you can check it out the table again. HF2, this one, that is 384.39 plus 0.8857. HFG2, it is all again given. It is 2278.6. 2278.6, my dear. Now I'll get S2, and S2 will come around. बच्चा पार्टी कितना आ रहा है S2? S2 is how much? कितना ही? 2402.54. 2402.54. 2402.54 kilojoule per kg. Okay, बच्चा पार्टी, I hope you got it. हाँ जी. Anybody have any doubts? Please let me know. Ashwini, Muthu, and anybody else, those who are watching. Guys, if you have came first time, then do hit like, share, and subscribe the channel. Okay. So my dear, this is your S2. Now you got S2. Now my dear, you can calculate W net, and that should be none other than S2 minus H1. S2 that is given, that is what, my dear? Sorry, it should be H1 minus H2. I'm very sorry. H1 minus H2. So H1 is given, that is none other than this much. Where? It is this one. 311.3115.3. S2, that is 2402.54. So your answer will be, my dear, कितना होगा इसका आंसर? इसका आंसर will be how much? Got it? Very good, Ashwini. What it should be? कितना आएगा? That should be none other than 712.76. कितना? 712.76. 712.76. Okay. Now my dear, we have to calculate WP, and WP is nothing but VF dP. So VF, it is given है question में, right now. It is how much? VF at 75 kilopascal. How much? अरे VF at 75 kilopascal. That is none other than this. This one, ये देखो दिया हुआ है 0.001037, right? So 0.001037 change in pressure. So pressure में change कितना है बच्चा? It is none other than what? 3000 minus 75, क्योंकि 3 megapascal है ना वो. So my dear, you will get WP, and WP will कितना आएगा बच्चा? WP will be around 3.03 kilojoule per kg. So my dear, W net will be what? WT minus WP. So this answer will be, बच्चा पार्टी कितना आएगा ये? It is 709.73. Okay, efficiency will be, my dear, then 709.73. Heat added कितना होगा बच्चा यहाँ पे? Yes, that should be H1 minus H4. कितना होगा? H1 minus H4. Very good. That is heat added. We don't know about it. So my dear, heat added will nothing but H1 minus H4. You can see in the diagram. देख पा रहे H1 minus H4, right? But my dear, WP is nothing but what? क्या होगा ये? WP H4 minus H3 क्या होगा? H4 minus H3 ना? H4 minus H3. That is 3.03, right? So from here, my dear, you'll get, because you know S3 तो आपको पता है. That is how much? S3, you know that. S3 is how much? S3 is nothing but HF ना, at 75 kilopascal. अरे भैया इस HF का मतलब H3 का मतलब what is H3? You can check it out in the diagram. S3 means HF at 75 kilopascal. That is none other than what? 384.39. Right? So my dear, S3 is what? 384.39. So my dear, from here I'll get H4, and H4 will be what? कितना आ रही है H4? H4 will come around 387.42. Right? This is your H4. If you got H4, now my dear, you'll get Q heat added. That is none other than H1 that you know already. H1 we have the value. कितना है बच्चा? 3115.3. 15.3 minus 387.42. So it should be what बच्चा? कितना आएगा ये? कितना आएगा? It is how much? कितना आ रहा है ये? Whatever it may be, जितना भी आ रहा होगा. Okay. So my dear, what you'll do now? Efficiency will be 709.73 divided by 3115.3 minus 387.42, and my dear, eta will be कितना eta? Eta will be how much? That is 26.01. Okay, this is the required answer. Yes, it's quite lengthy, but that is quite easy. Okay, bacha party, I hope you got it. Here I go for the next one, bacha. Here I go for the next one. See, in a three-stage air compressor, the inlet pressure P1, discharge pressure P4, and intermediate pressure P2 and P3. That is, P2 is less than from P3. Okay, the total pressure ratio of compressor is 10. The pressure ratio of the stages are equal. If P1 is equal to 100 kilopascal, the value of P3 in kilopascal is the value of P3. They have asked the value of P3 in kilopascal. Bachawadi, how we can see? See, my dear, I'll tell you. Actually, what is the arrangement? Here we have three-stage compressor, right? 3 compressor लगे हुए लाइन से. C1, C2, C3. Here pressure P1, here pressure P2, here pressure P3, here pressure P4. My dear, they said P2 by P1 is equal to P3 by P2 is equal to what, my dear? P4 by P3. Am I right now? यही बोला गया है, right? Now we have to calculate P3, right बच्चा पार्टी? हमें क्या कैलकुलेट करना है? P3 ना? So my dear, P4 by P3 multiplied by P3 by P2. देखो, and they said pressure ratio of the compressor is, that means P3 by P2 multiplied by P4 by P3, that is equal to what? 10. यही मीनिंग है इसका. Am I right बच्चा पार्टी? If it is so, my dear, then can I say, my dear, that is P2 by P1 cube, because they are equal, is equal to 10? Yes or no, bacha party? Can I say like this? Of course, I can say, right? Right now? Okay. So, my dear, now listen to me very carefully. Now listen to me very carefully. P3 is equal to, अगर P2 by P1 is equal to इतना हो गया, so can I say this is what pressure ratio? So can I say P2, okay, is equal to pressure ratio up into P1, right now? Right, हाँ या ना? Of course I can say. Of course I can say, right बच्चा पार्टी? Now P3 क्या हो जाएगा? P3 हो जाएगा हमारा what my dear? P3 will be what? P3 will be what? Number of stages ना क्या हो जाएगा? P3 is equal to what my dear? P2, sorry, P3 is equal to P1, that is 100 multiplied by 10 raised to power 2 by 3. So कितना आ जाएगा बच्चा? It is come around कितना आएगा? 464.14. 464.14 kilopascal. Okay, and this is we have already seen. कहाँ देखा है हमने? We have already seen in centrifugal multi-staging, right? इसमें उस चीज को देखा था हमने. Very good. Yes, guys. Had you got it? If you got it, then please tell me. If you have any doubt, then please let me know, my dear. We'll go for the next one. In Rankine cycle of the steam power plant, the turbine entry and exit enthalpies are given. Okay, the enthalpies of water at pump entry and exit are this much. The specific steam consumption, they are asking for specific steam consumption, bacha party. It's very easy question. We have already done this kind of questions, bacha party. Yes or no? Please tell me. Very good. So my dear, C. क्या होगा देखो. You know that WT will be what, my dear? 2803 minus, very simple question. That is this. That means what? 1003. WP will be what, my dear? 121 minus 124. That is what? 3 again. 124 minus 121. That is again 3. So my dear, W net will be what? 1003 minus 3. That is 1000. My dear, specific steam consumption, na? SSC. That is nothing but 3600 divided by network, that is 1000. So ये क्या हो जाएगा बच्चा? 3.6 kg per kilowatt hour, right? Number 1. I hope you got it, bacha party. I hope you got it. Very good. That's very simple question. Okay. So my dear, now I'll go for the next. Select the correct statement for 50% reaction stage in a steam turbine. 50% reaction stage जो turbine होगी उसके लिए correct statement क्या है इसमें से? हाँ जी बच्चा पार्टी. Which one is correct? Guys, B false. It's very simple question that you can answer, and it is none other than what बच्चा? क्या होता है इसमें? Rotor blade is symmetric? No. The stator blade is symmetric? No. The absolute inlet flow angle is equal to the absolute exit flow angle? No. The absolute exit flow angle is equal to the inlet, right? Yes or no? इसमें क्या होता है? Alpha 1 is equal to beta 2. Alpha 2 is equal to beta 1. VR1 is equal to what, my dear? V2. VR2 is equal to V1. ये होती है condition, right now? So this will be what, my dear? Option number 4 is going to be correct. Option number 4 is going to be correct answer, right? Yes or no, bacha party? Had you got it? अरे समझ पा रहे हो बच्चा पार्टी? Yes or no? Please tell me. बच्चा पार्टी, yes or no? Okay. चलें? Okay, बच्चा पार्टी. See here. Next question, please. See. Wait. A gas turbine with air as a working fluid has an isentropic efficiency 0.7. Okay. When operating at pressure ratio of 3. Now the pressure ratio of the turbine is increased to 5 while maintaining the same inlet condition. Assume air as a perfect gas with a specific heat ratio, that is gamma 1.4. Okay. If the specific work output remain the same for both the cases, the isentropic efficiency of the turbine at the pressure ratio of 5 is, my dear, क्या बोला है? The value of gamma 1.4. Specific work output remains same. Isentropic efficiency of turbine at the pressure ratio of 5 is what, my dear? We have to calculate what, my dear? Isentropic efficiency of turbine when the pressure ratio is 5, right? So, my dear, first we are going to see, because we have two cases over here. So, we'll see the cases one by one. एक एक करके cases को लेंगे, right? So, first of all, let me draw the diagram, my dear. ठीक है, diagram draw कर लेते हैं. So, diagram will be like this only. यहाँ पे diagram draw करते हैं. Okay, बच्चा पार्टी. I hope it's visible to you. Let me check. Okay, that's very good. It's visible. So, see. Okay, it is 1, it is 2, it is 3, my dear, what? It should be 4 and 4 dash, 4 and 4 dash. It is what? T, it is S, right? Now, my dear, see. Now I will write the expression for the isentropic efficiency. Okay, yes, anybody have any doubts, please let me know, bacha party. Okay, so here I go, my dear. So क्या होगा? टर्बाइन का एफिशिएंसी क्या होगा? It should be T3 minus T4 upon T3 minus, right? It should be T3 minus T4 dash. I'm sorry. The efficiency of turbine isentropic, that is what, my dear? It should be T3 minus T4 dash divided by T3 minus T4, right? Because ideally ज़्यादा होगा work, right now? Yes or no, bacha party? Of course it should be. Okay. So if you got it, if you got this point, my dear, now I'll go. Pressure ratio is 3, gamma is 1.4, right? So I'll put the values. But before that, my dear, before that, I'm going to calculate T4, right? T4 और T3 में relation निकालते हैं. Okay. See, my dear, let me check. Mahendra Yadav, very good. My dear, now see, you know that T4 by T3 will be what, my dear? It should be P4 by P3 raised to power gamma minus 1 upon gamma. So that will be nothing but equal to P4 by P3. कितना है बच्चा? It is given in the question, right? And it is how much? कितना है ये? बच्चा पार्टी, please tell me. Pressure ratio is given. That is none other than what बच्चा पार्टी? 3. कितना दिया हुआ है? 3. Okay? हाँ या ना? Of course it is, right? कितना दिया हुआ है? Okay. So see the diagram. Now P4 by P3, but they have given us P3 by P4, na? So my dear, it should be what? P3 by P4, that is what? P4 by P3, तो यहाँ पे क्या ले लेंगे हम? 1 upon 3 raised to power 0.4 divided by 1.4, right? So my dear, from here I'll get T4. T4 is equal to, किसके बराबर आएगा T4? So my dear, if I do the calculation, I'll get 0.73063. 0.7306T3, right? ये relation मिल गई हमें, right? Now what I'll do now, अब क्या करेंगे हम? I'll put this value, इसमें put कर देंगे, okay? See my dear, इसमें put कर देंगे value. So eta of turbine in the first case will be what, my dear? T3 minus T4 divided by T3 minus what, my dear? 0.7306 T3, right? Hayana, this is your first equation. Now my dear, we'll go for the second case. In second case चलते हैं. First case तो देख लिया, now second case देख लेते हैं turbine का, right? Now the pressure ratio is how much बच्चा? 5. So my dear, again pressure ratio is 5 ना? So see, can I say again T4 by T3 is equal to 1 upon 5 raised to power 0.4 divided by 1.4. So from here I'll get T4, and this T4 is equal to bacha party how much? This T4 is equal to 0.6318 0.631385 T3, right? So my dear, now I have efficiency T2 turbine. So that is nothing but T3 minus T4. So here I'll put what T3 minus T4 dash it is, okay. It is what 0.631385 T3, right? This is your second, okay. So this is your efficiency in second case. Now we got efficiencies in both the cases, right, bacha party? Now what I'll do, I will equate, right? And they said specific work output is same for both the cases, right? Hi Anna. That means specific work output is same in both the cases, right? Work output to same rahega, right now. So here, my dear, I will write S3 minus H4 dash in first case is equal to S3 minus H4 dash in second case, right now, right? First or second case में बराबर रहेगा. Now, my dear, can I say like this? That means if it is equal, so can I say T3 minus T4 dash in first case is equal to T3 minus T4 dash in second case, right? If it is so, my dear, if it is so, अगर हम ले लें, suppose to be if I took that is pressure ratio 5, so in that case what is our efficiency that I'm going to discuss, okay. So बच्चा पार्टी listen me, listen अभी ध्यान से देखना, okay, listen to me very carefully, okay. So here I go, listen to me very carefully, okay, it's good. Now my dear, I have eta 2 and I have eta 1. So my dear, can I say eta t2 divided by eta t1 that is equal to किसके बराबर आएगा? We are going to take a ratio. Eta t1 ये है हमारी, right? Eta t2 वो है हमारी, right? It is what, my dear? Again I am telling you, this is t3 minus t4 dash, right? And it is for first case and second case, both are equal, right now. So my dear, what will get? क्या मिलेगा हमको? What I'll get? I'm going to get, yes बच्चा पार्टी, what it should be? I'm going to get 1 minus 0.7306. मेरे पास क्या बचेगा? 1 minus 0.7306 T3 06 T3, right? T3 cancel out हो जाएगा, divided by what, my dear? 1 minus 0.631385 T3. ये गुजर जाएंगे, right now. So my dear, I'm going to get a ratio कितना जाएगा बच्चा पार्टी? The ratio will be 0.73084. ratio will be 0.73084. So if you get this ratio, my dear, now you can say eta 2 is nothing but this 0.73084 times, right now, right? So my dear, see now, my dear, eta t2 will be what बच्चा? क्या होगी? 0.73084 eta t1, and eta t1 is what, my dear? Eta t2, that is what, my dear? 0.73084 multiplied by 0.7. So from here you'll get the answer, and the answer will come 0.5116. This will be going to be answer. Yadav ji, had you got it? Mahendra, had you got it now, beta? Mahendra, had you got it? If you got it, then please do hit like, share, and subscribe to this channel, okay? So my dear, see, the properties are missing. I'll write the properties over here. First, let me write the properties over here, okay? Let me write the properties. Okay, yes, sir, that's great. So now let me write the properties first. Okay, I'll write, my dear, just it is state, okay? 1 2 3 4 5 6, and my dear, the another, that is 33502800. Here enthalpy 33502800. थर्ड स्टेज में कितना है? लेट मी चेक, दैट इज 2300175. इट इज 2300175556 का देखना पड़ेगा. लेट मी चेक. 700,000. It is 701,000. Okay, and these are what, my dear? These are enthalpies in kilojoule per kg. Okay, these are enthalpy, that is small h. States are given, each and everything, the diagram is given, right? And I hope everything is visible to you. Mahendra, is it visible? Mahendra, is it visible now? Visible hai? Mahendra, is it visible? Is it visible? If it is visible, then please let me know. Yes. Okay, that's great. So my dear, here I go. Now we have to calculate. What they said. Steam power cycle with regeneration as shown below in TS diagram employs a single feed water heater for efficiency improvement. The fluid mixed with each other in an open feed water heater. The turbine is isentropic and input to the feed water heater from the turbine is at state 2 as shown in the figure. The process 3-4 occurs in the condenser. Okay, 3-4. Okay. The pump work is negligible, that is WP is going to be 0, my dear. The input to the boiler is at state 5. Okay. The following information is available. The mass flow rate of steam bleed from the turbine as percentage of total mass flow rate at the inlet to the turbine state 1 is, my dear. We had to calculate, right, the mass that we extract for heating purpose, right? हाँ जी बच्चा पार्टी, दिमाग में बैठ रही है? Yes or no? बच्चा पार्टी, yes or no? Very good. बैठ रही है दिमाग में? Can I go for next? चलें आगे बढ़े फिर. Okay, listen to me very carefully now. आगे बढ़ें. My dear, देखेंगे आप. Let me draw the diagram first. एक अच्छा बेहतरीन सा डायग्राम मैं बनाता हूं पहले. Then I'll let you know each and everything. Okay, that will be better. Okay. Okay, so now listen to me very carefully. Okay, this is going to be the actual diagram, right? This is what 1. अच्छा पार्टी क्या होगा वो? 1 2 3 4 4 dash 5 5 dash 6, right? So here my dear, 1 2 3 4 4 dash 5 5 dash and this is going to be 6, right? My dear, यहाँ पे क्या रहेगा? मास m. यहाँ पे आपने हीटर लगाया है, राइट ना? सो माय डियर, यहाँ पे जो मास आएगा दैट इज क्वाइट व्हाट, दैट इज व्हाट माय डियर, m minus m1, बिकॉज यहाँ पे मास जो जाएगा दैट इज क्वाइट m1, राइट, फॉर हीटिंग पर्पस. यस और नो? यादव जी, महेंद्र, आई होप यू गॉट इट. महेंद्र, समझ आ रही है बात? हाँ जी, वेरी गुड. इफ यू गॉट इट माय डियर, देन आई वांट टू टेल यू, सी अब क्या होगा, ये जब जाएगा तो बैलेंस होएगा, 0.5 पे पूरा मास मिलेगा हमें, राइट ना? यस और नो माय डियर? सो कैन आई से माय डियर, कैन आई से, वेरी गुड. सो कैन आई से बैलेंसिंग इक्वेशन विल बी व्हाट, ये m2 ms2 हो जाएगा, m1s2 हो जाएगा ये. So it is what, m1s2 plus what my dear, m minus m1 into h4, right, is equal to किसके बराबर होगा ये? MH5 के 0.5 पे पूरा मास मिलेगा, that will get mix, right now. Balancing open feed water heater, if you remember my dear, ध्यान करो थोड़ा सा उसको. Okay, so my dear see, अब देखो ध्यान से, if I divide it by M, so क्या होगा? I'll get M1 by MS2 plus what my dear, 1 minus M1 by M H4 is equal to what my dear, H5, right? I'll put the values, get the answer my dear. M1 by M को X मान लेते हैं, अगर इसको X मान लें, supposed to be M1 by M is going to be X, then I'll go for the next slide my dear, see, then I'll go to X S2 plus 1 minus X H4, 1 minus X H4 is equal to H5, is equal to H5, right? हाँ या ना बच्चा पार्टी, ऐसा ही कुछ है. ओके, so my dear, can I'll write directly X is equal to X into H2 minus H4, that is X is equal to H2 minus H4 is equal to my dear H5 minus H4, right? हाँ या ना बच्चा पार्टी, of course I can write this, right? If you can write this my dear, now you'll get X आपको मिल जाएगा, right? Now you will get X, and that is equal to H5 minus H4 divided by H2 minus H4. So my dear, H5 it is already given H5 700, H4 175, okay, 175, S2 2800 minus 175. My dear, you'll get X. X आपका कितना आएगा बच्चा? X will be what? 0.2. कितना आ रहा है बच्चा? 0.2. That is 20. That is what my dear? 20. ये तो परसेंटेज आया ना. X1 is equal to what my dear? X1 is nothing but what? M1 by M, and that comes around 0.2. So my dear, M1 क्या हो जाएगा आपका? 20. This will be the correct option. ये क्या हो जाएगा? 20. Very good, Mahendra. Very good. M1 कितना हो जाएगा फिर? 20 ना? Very good. Your answer should be, remember, your answer should be 20 kg, 21, sorry, 20 kg. I'm very sorry. Okay, now I'll go for the next my dear. चलें आगे. For an ideal Rankine cycle operating between pressure of 30 bar and 0.04 bar, the work output from the turbine is 903. The work input of the feed pump is 3 kilojoule per kg. The specific steam consumption. Very simple question. महेंद्र जी, what should be the answer of this question? Please tell me. हाँ जी बच्चा. अरे सीधा सिंपल है. 4. अरे क्या होगा? W net will be what my dear? WT minus WC. W turbine का कितना दिया? Work output 903 minus pump work, that is 3. So it should be what? Now 900 and 3600 divided by 900. That is nothing but 4 kg per kilowatt hour, right? यही तो होगा आंसर. स्पेसिफिक स्टीम कंजम्पशन, राइट? ओके, महेंद्र जी, महेंद्र. ओके, बच्चा पार्टी विल गो फॉर नेक्स्ट. Air ideal gas enters perfectly insulated compressor at temperature of 310 Kelvin. Okay, pressure ratio of the compressor is how many much my dear? 6. Specific heat at constant pressure of air is what? 1005 joule per kg Kelvin. Ratio of specific heat at constant pressure to constant volume, that is gamma, 1.4. Assuming specific heat of air are constant, the isentropic efficiency of compressor 85%. The difference in enthalpies of air between exit and inlet of compressor is what? Kilojoule per kg. Round off nearest integer. Bacha party. Yes. How we can solve? It's very simple. It's very simple. Nothing. कुछ भी नहीं है इसमें. इस क्वेश्चन में कुछ भी नहीं है. I'll repeat once again. So बच्चा पार्टी, they are asking for the, है ना? Asking for the, see my dear, isentropic efficiency. Okay, so see, this is our Breton cycle. Right, and this will be your actual. sorry, this will be your actual, right? So it is bacha 1 2 2 dash 3 4, right? Now it will be like this only. It is TS, है ना बच्चा पार्टी? So if it is TS, then my dear, see here, क्या होगा ये? S2 minus H1 upon S2 dash minus H1, right? Now very good. It should be what? S2 minus H1 divided by what, my dear? S2 dash minus H1, and that is nothing but बच्चा पार्टी क्या है ये? W ideal upon W actual. It is your W ideal, W actual, and W actual will be more, right? So my dear, W actual will be nothing but what? W ideal divided by efficiency of compressor, right? So W ideal you can get, my dear, that is what? Cp into T2 minus T1 ना? क्या कर दोगे आप? Cp into T2 minus T1 divided by eta, that is compressor, and that will be around बच्चा कितना है वो? So here I'll go, that is what, my dear? S2, that is Cp 1005, T2, let me check how much it is. It is 310, no, 310. What about the ideal gas enthalpy? What is the actual value? 517.21 na? 5, T2 we have to find out, bacha. T2 we have to find out. Still we have not find out T2, right? T2 nahi hai hamare paas. So my dear, T2 we have to find out. T1 we know that 310, and it is 0.85. My dear, T2 by T1, that is nothing but P2 by P1 raised to power gamma minus 1 upon gamma. Gamma is 1.4. So from T2 by T1 is equal to pressure ratio कितना है बच्चा? Pressure ratio is how much? Pressure ratio is given na 6. Pressure ratio 6 is given. Okay. 6 raised to power 0.4 divided by 1.4. My dear, from here you'll get T1, T2, and that will come around bacha party. How much? 517.22. Kitna? 517.22. My dear, you'll put the value, that is 517.22 over here. You'll get W actual, and that will be, my dear, how much? Kitna आएगा वो? 245 kilojoule per kg. 245 kilojoule per kg. Okay, and this will be the required answer. Mahendra, had you got it? Mahendra, had you got it? Please let me know if you got it, bacha. Here I go for the next. Listen to me very carefully. The compressor of a gas turbine plant operating on an ideal intercooled Breton cycle accomplishes an overall pressure ratio of 6 in two-stage compression process. Intercooling is used to cool the air coming out of first stage to the inlet temperature of the first stage before its entry to the second stage. Air enters the compressor at 300 Kelvin and 100 kilopascal. If the properties of gas are constant, the intercooling pressure for minimum compressor work. My dear, you know that P2, that is nothing but under root P1 P3. We have already studied this, and it is what, my dear? Kitna hai yahan pe? That is 100 into how much, bacha? 2 stage hai, right? Intercool between overall pressure ratio 6, 2 stage compression, right now. So first stage, okay. So my dear, first we have to calculate. कि कितना होगा उसका, right? P2 by P1. So P2 will be what, बच्चा? P2 कितना हो जाएगा? P2 will be 600. Good afternoon, Tanmay Soni, most welcome. So intermediate pressure ना. So P3 will be what, my dear? P3 क्या हो जाएगा? P1, that is 100. What is 6 दिया ratio? That is what? 600. So this ratio is nothing but what, my dear? 100 into 600. राइट. सो इट शुड बी अराउंड, कितना आएगा बच्चा, ये कितना आएगा 244.95, कितना 244.95 किलो पास्कल. इट्स वेरी सिंपल क्वेश्चन. पहले आपको प्रेशर रेशो दिया हुआ था 6. By the help of that you can find out P3, and if you get P3, my dear, you know that for minimum work input, the condition is that intermediate pressure or intercooling pressure is nothing but under root of product of lower and maximum temperature, right? Sorry, maximum pressure. I hope you got it. Tanmay Soni, you are most welcome in the session, guy. Bacha. Okay, so now we'll go for the next one. Which one of the following is incorrect statement about regeneration in vapor power cycle? Incorrect, remember, incorrect. Incorrect, we have to choose, my dear. Incorrect, okay? Incorrect statement vapor power cycle के regarding. बच्चा पार्टी be fast. कौन सा होगा बच्चा पार्टी? be fast. See, my dear, I'll read the questions. Very good. It increases the irreversibility by adding the liquid with a higher energy content to the steam generator. Increases the irreversibility by adding the liquid with higher energy content to the steam generator. Heat exchange between expanding fluid in the turbine and compressed fluid. Right? There is no issue. It's correct. We have. I think this is incorrect. Increase the irreversibility. No. By adding liquid with a higher energy content. No, no, no. It does not. Does not. That is number 1. Right? बच्चा पार्टी number 1 is incorrect. Hi Anna. Hi Anna. Yes or no? It never. Right now? I hope you got it. नहीं होता है उससे. Okay, बच्चा पार्टी. Now I'll go for the next. My dear, see another one. Which of the following statement regarding Rankine cycle with reheating are true? Reheating के साथ में, with reheating are true. Increase in the average temperature of the heat addition, reduction in thermal efficiency, drier steam at the turbine exit. My dear, see what they said. Which of the following statement regarding Rankine cycle with reheating true पूछ रहा है? True. So you know that बच्चा, increase in average temperature of heat addition, definitely there is a mean temperature of heat addition increases. ये increase होता है. So definitely number 1 is correct. Right? Reduction in thermal efficiency, no. There may be an increase, there may be decrease. So there is, we cannot say that it may be increase, it is always decrease. No, it may increase or it may decrease. दोनों possibility होती हैं. So it is going to be incorrect. Dry steam at the turbine, definitely the dryness fraction has been improved by the reheating. Right now, कैसे होता है that I will explain. So my dear, number 1 and number 3 is going to be correct. Right? And my dear, one more thing that I want to tell you, those who came first time, my dear, I want to tell you that GATE PYQ series is going on 3 p.m. Delhi. 3 p.m. Delhi. Okay. Daily hoti hai. So guys, don't forget to attend this session, right? And I want to tell you on 24th from 11 a.m. My dear, I want to tell you there is a complete revision series for thermal science is going on. And it is a marathon session. It is of 4 hours. Thermal series. 4 hours hoga. Then we have 27th. We are going to revise all the subjects. Okay, bacha party? Okay, so Mahendra, that I want to tell you, don't forget, Tanmay Soni, don't forget to attend this session. I repeat once again, on 24th, we are going to take thermodynamics, whole thermodynamics, complete thermodynamics. Complete, okay? And it will be start from 11 a.m. 11 a.m. to 3 p.m. Then, my dear, in evening, same day, 4 p.m. 4 p.m. to 8 p.m. we are going for again TD, remaining part, okay, 8 hours. And my dear, then we have on 27th, again we are going for IC, RAC and power plant. These 3 subjects I am going to, and complete revision. And it is also of 4 and 4. That means 4 hours from 11 to 3 and then 4 to 8. That means it has been also divided into two parts. Okay, bacha party, I hope you got it. So guys, don't forget. And guys, those who came first time, they can join. They can hit on a like button, or they can share the channel, as well as they can subscribe the channel. So my dear, you will get latest notification from us regarding whenever there is any live class related to the mechanical engineering, right? So bacha, do hit like, share and subscribe the session. And supposed to be, if you have any kind of a query, you can just WhatsApp your queries on this number. Okay, I hope you got it, bacha party. It's clear now. Done. You can just WhatsApp your queries on this number. Okay, bacha party. Okay, Mahendra. So guys, we'll see you in the next session then. So thank you so much for your patience, for listening me. And guys, once again, that I want to say, if you have came first time in this channel, then my dear, do hit like, share and subscribe the channel. And one more thing that I want to tell you, that if you are interested in SSC JE Mechanical Live Coaching, my dear, then you have to fill the application form, and the link of that application form has already provided in the description of this video. Okay, my dear. And one more thing, that is Testbook Pass. Now you're getting 14 months validity. And in additional to that, my dear, you are getting Ghana Plus subscription for 3 months free of cost. You can explore the pass or mock test in the website as well as in the app, my dear. Okay. So guys, these are the offers and opportunities for you guys by the testbook.com, so you can explore and get benefit of this session, right? So bacha will see you in the next session, my dear. Okay, and if you have any kind of a query, you can just post me on that number. Okay, so guys, we'll see you in the next session. Take care. Bye bye. Shapa khair. One more thing that I want to add, please stay at home, stay safe, stay online with testbook.com. Jai Hind, Jai Maa Bharati.